Welcome to Madhouse TV physics class. So we are looking at units of measurements. Measurement is comparing or to determine the quantity or the amount of a matter by comparing it with a standard. At every point in time that measurements have to be made, there must be what? A standard unit that is used for the comparison. Now in science we have what? An internationally accepted what? Units that have been set apart for all measurements. This international unit is referred to as what? The SI unit. The SI unit simply stands for what? The System International Unit. And in our System International Unit, we have basically 7 quantities that have been accepted as what? The foundation or the basic quantities for measurements. They are referred to as what? The fundamental quantities. And these fundamental quantities, the units for measuring each of them is now referred to as what? The fundamental what? Units. We are going to look at our fundamental quantities and the fundamental units under our SI system of units. Now let's look at that fundamental quantity. Fundamental quantities. And we have our SI units. SI units. Now let's look at that. The first or one of them is length. Length. Length is a fundamental quantity. We also have mass. Mass is a fundamental quantity. We also have time. Time is a fundamental quantity. Then we also have temperature. Temperature is a fundamental quantity. We also have electric current. Electric current. Electric current is also a fundamental quantity. Now let's look at each of these quantities first and see what is their SI unit. The SI unit of length is the meter. The SI unit of length is meter. The symbol for meter is small letter m. Then we have mass. The SI unit of mass is kilogram. Kilogram. The symbol is kg. We also have time. The SI unit for time is second. The symbol is small letter x. Then we have temperature. The SI unit for temperature is Kelvin. The symbol is what? K, capital K. And we have electric current. The SI unit for electric current is the ampere. These are some of the basic, or what we refer to as our fundamental quantities. We also have 2 more fundamental quantities. One, we have the luminous intensity. Luminous intensity. Luminous intensity have a unit called the candela. CD. That's the unit. It's called the candela. CD is the symbol for luminous intensity. Then we can also talk about what? Another unit we can call the quantity. Quantity of substance. Quantity of substance. The SI unit for it is referred to as the what? The mole. And the symbol is MOL. Mole. But for our quantity of substance, most times it's more or less used under what? Chemistry. When we are looking at chemicals and other substances, the quantity of substance. These are the basic what? Fundamental quantities and their fundamental what? Units. Now, their fundamental units are usually referred to as what? The SI units. So we are going to look at derived quantity. Now each of these derived quantities, they have a derived unit from our SI unit. Now what is derived quantity? A derived quantity is a quantity that is got from various combinations of our fundamental quantity. So when our fundamental quantities are combined in various what? Proportion or ratios, they give us a new set of quantity referred to as what? Derived quantities. Now let's take that down. So we say derived quantity. Say these are quantities got from combination of various what? Fundamental quantities. So when we combine our fundamental quantities in different pattern, in different ratio or proportions, we are going to get new quantities that are called derived quantities. And the units of these derived quantities, we can refer to most of them as what? A derived what? Units. So we have derived quantities and we have derived units. But we also have what we call our SI units. The SI units may be different from the derived units of a particular derived quantity. I would like to state that again. I said that under our derived quantities, some of them have what? A particular unit that is given to them in respect to the names of the founder, and that is referred to as their SI units. So for our derived quantities, we may have difference between the derived units and their SI units. We are going to look at some of them. But before we look at that, let's concentrate and look at some of our derived quantities and the derived units. So we have derived units. We can say what? These are what? Units. These are units of derived what? Quantities. They are units of derived what? Quantities. These are derived units. Now let's look at some of our derived quantities. Example. We have speed. Speed. We have acceleration. We have acceleration. We also have power. We have force. We have walk. We have pressure. We have velocity. etc. etc. All these are what? They are examples of derived what? Quantities. All these are examples of derived quantities. Now, they have their derived units, and some of them have what we refer to as their SI units. So, we are looking at some of the derived quantities. We are also going to look at their derived units. Now, we call them derived quantities because they are generated from various combinations. Now, let's look at this. For example, speed. How do we get speed? Speed is given as what? Distance over time. And what is that? Distance over time. And distance is what? Length. Distance is length all over time. So you can see that it is a combination of what? Our fundamental quantity. So if we want to look at the derived quantity of our speed here, what is the unit of length? The unit of length is meter. And the unit of time is second. So this becomes what? The derived unit of what? Speed. Meter per second. Let's look at another one. Acceleration. Acceleration. Acceleration is given as velocity change. Basically, we say what? Velocity all over what? Time. Velocity all over time. And what is velocity? Velocity is actually what? Distance over time. Or we say what? Length over what? Time. Times 1 over what? Time. This is our velocity. Velocity and speed, they are the same in respect to what? Their quantity or their unit. So we have length over time for our velocity here times 1 over time here. So how many time do we have here? We now have what? 2 time. So we now have what now? Length over what? Time times time. And if we want to write out the units for our acceleration now, it now becomes what? Meter for our length per what? Per time per time. That's why we now have what? Meter per second squared. We have 2 time here, gives us what? Second squared. Please don't forget to share, like, follow, and comment on all our social media platforms and subscribe. God bless you.